Hi everyone, my name is Layale HACHEM. I'm a solutions engineer at BeyondTrust, and today I'm going to be discussing the zero trust model and architecture, and hopefully map BeyondTrust solutions to the entire zero trust concept. So a small agenda for this session. Just before we start, we're gonna discuss the zero trust architecture and model, answer some questions about zero trust, such as what is it, why was it created, what components contribute to a zero trust model, and then we're going to discuss how privileged access management solutions in particular can help you achieve a zero trust strategy in your environment, and wrap up with a small demonstration about BeyondTrust secure remote access and privilege management solutions. So in this first section, I'm going to try to answer a couple of questions. Question number one is, why was zero trust created? And zero trust was created based on the realization that traditional security model operated on a wrongful assumption. And that assumption is that everything inside an organization's network should be by default trusted. So traditionally, companies implemented controls that made it hard to obtain access from outside the network. But the problem is that everyone inside the network and whoever gained access to that network was trusted. So that was the problem with this approach, is that once the inevitable happens and an attacker gains access to the network, by exploiting vulnerabilities in that perimeter we were trying to desperately solidify, they have free reign over everything inside. Moreover, that perimeter was never a solid control, because we needed to account for remote users' access, third-party access, internet traffic, etc. So attackers started to use techniques and methods that allowed them to bypass our traditional security controls, such as gateways and inspection points. So we started to see a lot of encrypted traffic, zero-day malwares, and also attackers started to target personal devices whenever these devices were allowed to be utilized within a company network. So this is why zero trust was created. Now, two facts contributed to the rise of the zero trust model. One, companies no longer have their data in just one place. Data is actually scattered between on-prem and cloud, and sometimes it's even multi-cloud. And two, users, devices, application workloads are now everywhere. And this was in particular accelerated by the whole work from home situation. So that would answer the question of why zero trust is a buzzword right now. As a result, the industry quickly realized that this perimeter is no longer enough to protect valuable data and business operations. Instead of one big perimeter, we actually need to create multiple smaller scale perimeters around critical information technology systems and resources. In fact, this is what NIST describes as enclaves in its finalized guidance on zero trust. Enclaves, by definition, are essentially bubbles around data access that, like microsegments, are focused on data rather than network rights. So this means we need to shift defensive strategies. We need to put security controls as close to data as possible, creating micro perimeters around data instead of one big perimeter around data centers and networks. Once these micro perimeters are created, then we need to make sure that the right users need to have the right access to the right applications and data at the right time. And the notion of time here is very important, because this access should never be standing. At the contrary, we should be evaluating users and applications requesting access to our resources every time a request is made. So what we're doing here is that we're moving from the famous castle mode security model, where we have solid peripheral defense, but no control and wide open inside, to really a multi-level security approach that contextually assesses access all the time. So now, in order to shift to a zero trust model, we need to make a new assumption. An assumption that every user, request, and device is untrusted and will be treated as untrusted until proven otherwise. A zero trust approach dynamically and continuously assesses trust time a user or device requests access to a resource. So the obvious question here is, what is a resource? And I'm going to reference NIST again here, and NIST states that all data sources and computing services are considered resources. In fact, NIST also defines 7 core tenets of zero trust, and 2 of these 7 are directly related to access controls. And these 2 tenets also promote minimal access in both size and time. These controls can be accomplished, these access controls can be accomplished by verifying the 3 principles that you can see here on my slide every time a user requests access to a company resource on a per session basis. So it has to be time bound. First, we need to verify the authentication. We need to verify the user identity. We need to make sure that the identity is valid and that it was not compromised. Next, we look at the transaction. We need to authorize the transaction. We need to answer questions such as, are users or applications authorized to access a particular system? And moreover, what are they authorized to do on that system? And next, we need to evaluate the context of the transaction. So we need to tie that transaction to other parameters. And to do that, we need to answer questions such as, what time is the identified and verified user authorized to perform the transaction? On what date? From which location? Etc. These conditions must be verified every time a resource needs to be accessed or a transaction needs to be made. So next question is, how can we implement zero trust? And zero trust is an architectural approach. It's not a product. And the real answer is that no specific technology is associated with zero trust architecture. It is actually a holistic approach to network and endpoint security that incorporates several different principles and technologies. You need products, controls, and solutions to implement zero trust architectures. And definitely no single product can do it all. To put it into perspective, and since zero trust is not a one solution approach, moving forward, any security technology needs to serve the zero trust purpose. And possibly one of the first technologies that shifted to a zero trust mindset is network firewalls. We were so used to perimeter firewalls, and we wanted to protect users from internet-borne threats and attacks. And unfortunately, that proved to be not sufficiently efficient. But in recent years, firewall vendors tackled the zero trust architecture by rightfully positioning their firewalls inside data centers. And they started promoting network microsegmentation. Microsegmentation means that we are further shrinking the perimeter to protect data center services. And we're inspecting traffic between application servers in the context of a well-defined authorized transaction. Another important control and NIST tenet is continuous monitoring. This is equally important because once access is granted, firewalls, access controls, authentication measures, all of these proactive security controls are all no longer effective. Should we trust the user in a session? Should we trust traffic across a network? And the answer should be no. Because the reality is, attackers might always find techniques to bypass and overcome security controls. And this is why we should have complete visibility over authorized transactions. And we should be able to execute instant reactions in case we detect anything that is unusual. And these reactions should include measures such as dropping a session or blocking a user, etc. A couple of examples of different technologies that contribute to the zero trust architecture includes continuous diagnostics and management. This includes endpoint and network continuous monitoring, policy enforcement points, including firewalls, cloud enforcement points, such as cloud access security brokers, etc. So now, how can privileged access management vendors in particular help? And of course, I'm going to focus on BeyondTrust. BeyondTrust created a universal privilege management platform. that creates just-in-time access for every privileged user every time a transaction needs to be made. This platform actually joins BeyondTrust solution for privileged password management, endpoint privilege management, and secure remote access under one interface for unified visibility and control. And this is unified visibility over privileged activities in an environment. And if we start with PAM, privileged password management, PAM discovers privileged credentials across a wide range of platforms, automatically onboards the privileged identities to its vault, and then establishes access workflows for users' privileged access. So if we map this to the three principles we talked about, which are identity, transaction, and context, we first start by identifying end users. And for this purpose, PAM can be integrated with complementary authentication solutions such as multi-factor authentication or single sign-on. Then, according to a well-defined role-based access control policy, users are granted access to systems they are authorized to access using privileged vaulted credentials. These access policies verify that the user access is only granted in an acceptable context. And that an example would be here, for an example, allowing users to access critical servers whenever they are sitting within a corporate network versus blocking that access if they are trying to access from a home network. And after a user establishes a connection to its target server, then PAM monitors that session and records it for future review. And next, in the middle, we have endpoint privilege management. Endpoint privilege management manages the access of privileges on users' desktops and servers by allowing users to log in with standard user rights and elevating only specific applications and tasks on endpoints. In addition to privilege management, EPM incorporates pragmatic application control capabilities to only allow trusted applications to run on endpoints. Again, we start by identifying the user on the operating system, we verify the transaction, we create granular policies to only allow execution and elevation of trusted applications. And then we only allow that transaction, which is application elevation or application execution in that case, in the context of a well-defined policy that is tied to strict time, date, and location filters. And the final component here is secure remote access. And secure remote access extends privileged access management capabilities to external networks by actually replacing VPN with an HTTPS connection. Before access is granted, again, we verify the user identity. Then, according to role-based access control settings, remote employees and third-party vendors are granted access to systems and privileged accounts. And once a session is established, we also constantly monitor that session for unusual behavior detection. So moving forward, I will be focusing on endpoint privilege management and secure remote access solutions to discuss and showcase how these two solutions in particular can positively contribute to an organization's zero trust strategy. First, let's focus on secure remote access. And with secure remote access, the main objective is extending privileged access management capabilities to the remote workforce. So whether these are remote employees trying to reach their desktops and systems from home in a work from home situation, or whether these are third-party vendors that want to access internal systems and network devices. The way it works is actually by eliminating the need for these users to connect back to the corporate network using a VPN connection. And the reason we do this is that we don't want to invite untrusted devices to our trusted network. These could be personal devices that are managed by other companies. These devices are not managed or secured by our organization and therefore should not be trusted or granted VPN access. So what we do is we replace VPN with a more secure connection. Users will be able to access the appliance and internal systems through a published web application and an HTTPS connection. Once we provide them with this secure remote way of connecting, next action item would be user authentication. And we can do this by integrating with existing authentication directories, enforcing multi-factor authentication and single sign-on, etc. Once the user identity is verified, then we look at the transaction to check if that transaction is authorized or not. So we start answering questions such as what type of access is being requested? Is it server, network device, application access? The request, based on its type and context, can go through an additional approval process as well. And the final protection layer before actually initiating the session is injection of privileged accounts into remote sessions. This means privileged credentials are not shared with end users or given to external third-party users. By doing so, we reduce the window of opportunity for attackers to be able to steal or abuse these privileged credentials. And an absolutely critical point to consider in the zero trust approach is that we need to only grant access to a resource according to the least privilege concept. This means once a decision has been made dynamically to grant access, end users should log in with standard accounts to servers and desktops. Admin privileges give end users the potential of executing activities that attackers utilize normally in their attacks. So it gives them unlimited access and control over an endpoint. Administrators can change security settings, install applications, uninstall software, disable services, delete log files. All of these activities are techniques used by attackers to launch attacks in a network. And therefore, it is crucial that the context of a session be limited to the context of a standard user session. So we extend the no trust rule to applications and tasks running on the operating system. So what we do with EPM is actually allow users to log in with standard user rights and only elevate particular applications and tasks using the EPM agent, according to the authorization policies we put in place. By default, no application should be trusted unless it meets the trust criteria our policies mandate. Each application running on the operating system will be contextually evaluated and will be treated according to policy. This assessment is once again dynamic, and policies are based on user, time, date, host, and location filters. And even when an application is allowed to run or be elevated by policies, should we really trust it? Attackers take advantage of trusted applications to launch their attacks. The 2020 Verizon data breach report revealed that Office documents and Windows applications remain the preferred malware file types of attackers. PowerShell attacks are also always on the rise. So this is why BeyondTrust Endpoint Privilege Management also provides trusted application protection capabilities. And trusted application protection adds context to the process tree of an application, allowing restriction of common attack chain tools such as PowerShell and VBScript that are spawned from commonly used applications such as browsers, document handlers, Word, PowerPoint, Excel, and other types of applications as well. This means that when a user is tricked, such as via a phishing email, into opening a malicious document, the ransomware payload or script is automatically blocked from launching. This capability is an effective measure of defending against common attacks that look at exploiting trusted applications in the user environment. So what I'm going to do next is show you a small demonstration that is focused on secure remote access and endpoint privilege management. And to do that, we're going to go through 4 different use cases. And let's start with use case number 1. So use case number 1, I have a user called Dan. Dan works in an organization called BT Lab. Dan is my marketing specialist. He's currently sitting at home trying to access his own desktop back at the company office. It's a normal working day and Dan is within office hours. So what Dan is going to do is access the PRA appliance that is published for external access. And once Dan wants to authenticate, since he is an employee of the BT Lab organization, he's gonna use SAML authentication. And he's gonna provide his email ID as a first authentication layer along with his password. So next, he's gonna be prompted for his password. And he's gonna request to sign in. The next thing that will happen is that Dan will receive on his mobile phone a notification from Microsoft Authenticator asking him to approve the sign-in request using his biometrics. So this is an additional authentication layer that we've added, and what we're doing is we're constantly raising the bar and verifying Dan's identity. Then Dan will be able to access his web access console, and within that console, Dan only has access to the BT Lab desktop's workgroup. Under that workgroup, Dan can only see his own desktop and jump to his own desktop. So this is what Dan will attempt. He will attempt to connect to the desktop that is placed in the company's office. Once the connection is established, Dan can provide his AD credentials to access the desktop. After logging Dan in, the next thing is that we've talked about the least privilege concept. Dan should not be an administrator on his own desktop because Dan can abuse admin privileges, and any attacker that gains access to that system can abuse these admin privileges. So what we're going to do is that we're going to log in Dan as a standard user and then manage particular privileges on the operating system using the APM agent. A first example would be, let's say Dan wants to install an application such as Notepad Installer. He tries to launch it. He accesses a web browser. Then he downloads the installer and tries to launch it on the machine. What will happen is we're gonna actually replace the Windows UAC message, the message that would normally request admin credentials from Dan, with a flexible message that would grant the installer admin privileges more easily. This is because we have evaluated Notepad Installer. We know that Notepad Installer is trusted, it has a known publisher that can be verified, it's running from a path that is allowed, etc. We've verified the different criteria of Notepad Installer, and we've dynamically made the decision to allow this executable to run on the machine. And we said this is not gonna be a hard process for Dan. He can simply run it with admin privileges by simply selecting a reason for this installation. So he picks the reason and then he launches the installer, and automatically Notepad Installer will be able to run on the operating system with admin privileges. So what we did here is not only did we allow Dan to remain productive on his machine without admin privileges, we've also significantly reduced the load on the IT help desk team, because otherwise Dan would have gone to IT help desk, to the support team, and requested that someone accesses his machine and provides those admin credentials to that installer for it to be able to run on the machine. Another example would be, let's say Dan wants to try and install 7-Zip on his desktop. 7-Zip is an application that is requesting admin rights, that does not have a known publisher. We cannot trust it. So we have dynamically made the decision to restrict that application. And the way we do it is by replacing the UAC message with a restrictive message this time. And this is what we call a challenge response message. So Dan is presented with a challenge, and if he wants to run that application on the desktop with admin rights, he needs to contact IT help desk, tell them I'm trying to install a 7-Zip and I need the response code to that challenge I'm presented with. Dan can automatically do that from this message if we integrate it with ITSM solutions, or he can simply take that challenge, pass it to IT through email, maybe it's Teams, WhatsApp, etc. So what will happen is The help desk team will have access to what we call a challenge response code generator. They have a shared key that they will put here, and then they will enter the challenge code received from them. So 8675550 And once they put this challenge received from Dan, what they can do is they can decide whether they want to generate a response to that code that is valid for only a one-time use, whether they want to generate a code that lasts the entire session. So every time Dan tries to reinstall that application within the same session, it will be allowed to run, or whether they want to generate a code that lasts forever. So anytime Dan tries to reinstall that application on his desktop, he will be able to do it. So even that response code is tied to user and to location and to a time filter. So for now, we're gonna only generate a one-use only code. We're gonna provide the response code to Dan. So 706.380.44. And Dan will be able to run that executable with admin rights on his desktop. So what IT could potentially do is allow this installation only for one time, then make a final decision on whether they want to allow 7-zip to run in their environment, yes or no. And in case it's a no, then they can edit their APM policies to block that application for everyone. A final example on Dan's desktop is, let's say Dan wants to use an application that is simply prohibited by IT. So uTorrent, for an example. So uTorrent is part of the blacklist that is defined by IT, so automatically it will be blocked for Dan and everyone else who tries to run it in the environment on any desktop or machine anytime. So IT can make decisions on blocking applications that are not for business use, blocking applications that could be labeled as vulnerable, etc. So I'm gonna close Dan's session and move to use case number 2. So in use case number 2, we have a user called Sarah. And Sarah is my IIS and database administrator. And Sarah is trying to access the server she is responsible of from a remote site on a normal working day and within office hours. So she is again part of my BT Lab organization. So she has her own identity on my Active Directory. She will access the published URL of the PRA appliance. And she will use SAML authentication. Once a login request is raised, she will again provide her email ID. Next, she's gonna be prompted for her password. And after that, she's gonna receive the same notification, the same multi-factor authentication, requesting her to approve the sign-in request using her biometrics. So she's gonna approve it. And then she will be redirected to the PRA appliance. Again, this is the identity. We're verifying Sarah's identity. We're making sure that Sarah's identity has not been compromised by requesting her to give us her password, to go through the multi-factor authentication process, etc. Sarah will launch her web access console, and first thing we can notice is that Sarah has access to a different set of workgroups. Dan only had access to the BT Lab desktop's workgroup, where only his desktop was accessible from his console. Now for Sarah, she has access to do different workgroups. One workgroup is called Windows servers, another workgroup is called applications, and within that workgroup, she has access to the server where the database is installed and where the IIS manager exists. So now Sarah will attempt to jump to that Windows server. in order for her to do the administration part on the Windows operating system, she needs privileged credentials. And this is a fact because a lot of the activities that she will require to do on the operating system require admin privileges. But we have talked about how we need to enforce the least privilege concept, so we need her to log in with standard user rights. So Sarah, first of all, has the option of injecting a database privileged user into that session. Sarah doesn't know the password of the database privileged user. That password is vaulted within our solution, so it's protected by our solution. She cannot use it outside of this session because she simply doesn't know the password. And this is very important. She will automatically inject that privileged user into this session. But whenever I say privileged, that doesn't mean that the user is an administrator on the operating system. This means that it's a user that has particular privileges over specific applications and tasks on the operating system using the Endpoint Privilege Management agent. So as part of the database maintenance and IIS server maintenance, Sarah probably needs to access services and be able to restart the SQL service, for an example. So I will open services, and if I go to the SQL service and attempt to restart it with the database privileged user account, you can see that this user has the right to restart that service. So if we click on restart, we're going to see the EPM notification here that states that this particular service has been approved, audited, and elevated by EPM. Same thing if Sarah tries to access the IIS service and restart it, then she will be able to do it. And this elevation process is again approved and authorized by the EPM agent. But if she tries to restart any other service not related to her role as a database and IIS admin, then she won't be able to do it because she's a standard user. And this is a normal behavior for a standard user account on a Windows server. As part of her job as well, she probably needs to access the IIS manager. So if we open the INET manager, this is again an application that normally requires admin rights to run on an operating system. So through the EPM agent, we have elevated this application for Sarah. The context is Sarah's session. It's during office hours on a normal working day. She's using the database privileged user. It is her role, so we've decided to elevate that application for Sarah. If she opens PowerShell and tries to execute a couple of commands related to IIS, so let's go to PowerShell and open a PowerShell session with a local computer and execute the get-service command. Get-service will not be elevated. And you can see here the error on my screen that states that this particular operation requires other privileges. And the database privileged user is not an administrator account, so it will not be able to execute such a command that requires the admin privileges rights. But if Sarah tries to get some information regarding the IIS output, then she will be able to do it because it's related to her role, because it's Sarah, we have verified her identity, and because we need to allow her to execute that command in order for her to remain productive on that operating system. So I'm going to close this. And let's say Sarah now wants to try and access the resource monitoring tool on the operating system. So again, I'm going to go to that particular application, launch it. Normally, this wouldn't have been approved for Sarah, but we have evaluated the resource monitoring tool. We know that it's owned by Microsoft, it's an operating system task, it's trusted, it's signed. So we can allow Sarah to use it. And we can do it by replacing the normal UAC message by a simple yes or no message. So if simply Sarah clicks on yes, this application will be able to run with elevated privileges on the operating system. But let's say Sarah tries to allow remote access to that machine. So I'm gonna open Control Panel go to System and Security, click on Allow Remote Access. This is an application that has the same set of criteria of the resource monitoring tool. It's owned by Microsoft, it's native to the operating system, it's trusted, etc. But you have made a different decision and you have interacted with this application differently. And this is because potentially this application could open the door for attackers to gain access to my operating system. And we don't want to allow it. So we have labeled it as a restricted function. And this is why it's treated with a challenge response message. So in case Sarah has a valid reason for executing this activity on the operating system, she will need to contact IT support and only then can they approve it. So I'm going to close this and look at one final example on within Sarah's session. If we open Group Policy Editor, you're going to automatically see that she does not have the rights to change or mess with the group policy, and this is normal again because it's the context of a standard user. So we have really extended the no trust and the evaluation process for every request to specific applications and processes running on the operating system. So we're constantly evaluating who is the user, what is the application, what are the different criteria of this application, what are the date, time, location parameters of that access, and then we make a decision on an application and process basis. So I'm going to close this and move to my third use case. For my third use case, let's log out at first. Okay, so for my third use case, we have a user called Chris. Chris is as well an employee of the BT Lab organization. Chris is trying to access from a remote site his network devices and servers, again, that are in the company's office or in the company's data center. It's again a normal working day, and this access is attempted within office hours. So Chris will connect to the PRA appliance the same way his colleagues did. He has his own identity in my Active Directory, so he's going to be able to use SAML authentication. It's going to redirect us to the Microsoft single sign-on page. Then Chris will provide his email ID. Then provide his password as the next step in the identity verification. And after that, he will need to approve the sign-in request from his multi-factor authentication application on his mobile phone. Once Chris gains access to his web access console, you can see that he has access to a large number of workgroups, including Linux servers, web applications, Windows desktops, and Windows Server. First thing that Chris is going to attempt is to jump to that same server where Sarah was working. Once Chris needs to establish a privileged access, then he will be able to inject privileged credentials to that session. Again, we don't give the password of these privileged credentials to end users. These are all vaulted in our solution and automatically secured by our solution and injected into sessions whenever requested. Of course, based on a session basis. So he has rights to inject a user called sysadmin privileged user. This is again a standard user account on the operating system. So this is not a Windows administrator account. So I'm going to attempt to launch with the sysadmin privileged user the same set of tools and applications that Sarah attempted to launch in her session. So let's start with services. So Chris attempts to launch services within that session, and you're gonna see that services is entirely elevated for Chris. So it's not only about particular services that can be restarted, started, stopped with the APM agent. Every single service, except for the APM service, of course, can be restarted with once the services application has been elevated on the operating system. So we have granted services entirely admin rights on the operating system. Now, if Chris tries to open PowerShell and execute the same commands Sarah attempted, so he's gonna first of all open a PowerShell session to the local computer and attempts to get the IIS application pulled, then he cannot do it because he does not have sufficient permissions. He is not an administrator on the operating system. But if he attempts to get the service list, then he will be able to do it because this command in particular has been elevated by the APM agent. Another example would be if Chris wants to look at group policy. He's the system administrator again, so he should be able to do it. So we're gonna elevate it for Chris. But let's say Chris wants to allow remote access to that service. So he's gonna access control panel, go to system and security and click on allow remote access. What will happen is, even though Chris is my administrator on the server, we've talked about how this could potentially open the door to attackers to have access to my operating system, to my server. So we've replaced the UAC message with a more flexible message, but we're still asking Chris to re-authenticate himself and to validate that this is a transaction he wants to execute on the operating system. We're going to inform Chris that he is going to be monitored and this activity will be logged and audited. So we have requested that Chris provides a valid reason, and we have requested that Chris re-authenticates himself before he can actually allow remote access to that service. So simply he can provide with a valid reason and put a password here. So we're gonna authenticate him, and only after that will he be able to change the remote access settings on the operating system. We could also enforce Chris to go through an additional multi-factor authentication process at that stage on the process elevation layer. So whenever the process will be elevated, whenever we prompt him with a message, we can also prompt him to provide multi-factor authentication again. So I'm gonna close this. And the final example that I want to show you here within Chris's session is, let's say Chris tries to go to computer management and he wants to bypass the security controls we have in place and probably add himself to the local administrator group. So he goes to groups, look for the administrator group, and look for his account. So we're gonna try and find Chris's account and add him as a local administrator in that group. So he can do it since the process is elevated. So whenever I launched computer management, you notice that the process itself is elevated through the APM agent. And we have tried to add Chris. Whenever we are going to apply this, you are going to see that access will be denied. And this is normal because we have what we call anti-tampering techniques that are incorporated in our APM agent. This means no process can actually mess with the security settings we have in place. And of course, no user can add himself as a local administrator to the operating system. So we protect our security settings and we protect the settings of the operating system from any attempt to bypass these security controls that we are enforcing. So this is due to our anti-tampering techniques that we have incorporated in our APM agent. What we'll do next is that we'll close this Windows session, and I'm gonna jump to a Linux server. So here, Chris has access to a Linux server. He's gonna jump to that server, and he can as well automatically inject privileged credentials into that session. First thing you notice here is that Chris is allowed to inject the same Active Directory credentials to this Linux system. This is because we have as well BeyondTrust Active Directory Bridge solution installed that would allow us to unify authentication across Windows and Unix Linux system. So we will provide Chris with through single sign-on capability across the different systems, and it's going to be a true Kerberos authentication on that system. So he will have his own Kerberos ticket. So we will inject that Active Directory account to the Linux server, and if I type ID, you will be able to notice automatically that Chris is actually part of my domain users. So this is just to confirm that this is through Active Directory bridging, and we have injected an Active Directory credentials to that Linux server. So we've talked a lot about the least privilege concept, and we said that we need to only grant access to specific systems and servers according to the least privilege concept. So this extends as well to Unix and Linux systems. We need to allow users to log in with standard accounts to those systems and work productively as well. So this means we also need to be able to elevate particular commands and tasks on the Unix and Linux system using the EPM solution. And this is what we have in this case. So you are going to notice here that Chris will attempt to execute a couple of commands on that Linux server that require root or sudo privileges. So we're gonna start with Chris attempting to restart the firewall service. So he's gonna type systemctl stop firewall d. And the first error you can see here is that this particular command requires root privileges, and we don't know the password of the root account. So we're gonna cancel it. And to attempt it once again using the EPM agent, I will add a pbrun word just in front of that command. And you can see here that we got a different response. And this time we've actually consulted a policy entity, and this policy entity or policy manager actually rejected the execution of the systemctl stop firewall d command. So even though this could have been elevated, of course, we don't want allow Chris to restart or mess with the firewall service on the Linux system. Another example is, let's say Chris wants to attempt to restart another service. Start sshd.service. So again, this command requires root privileges. We don't have the root password, so we will cancel it. I will add the same pbrun word in front of that command. And you will see right now that this time it was also processed by the policy manager, but it was accepted as well. So we were able to grant that particular command root privileges using the endpoint privilege management solution that we have in place. Also here, I need to note that this command execution or this command elevation can also be tied to very strict conditions. So we can tie a command elevation decision to date, time, user, host, location. So we could enforce all of these conditions and constraints again to the command elevation process. And I'm gonna close this Linux session and show you one final example within Chris's session. So Chris, as we said, is our network and system administrator. So he's probably also the administrator on the SIM solution. He needs access to the web interface of that solution. So what we could also do is allow Chris to automatically access that web interface and automatically inject the SIM administrator credentials or privileged user credentials into that SIM solution, into that SIM web interface. And one thing to note here is that up until now, all of our access requests have been auto-approved, contextually, of course. So now Chris is jumping to the web application, and within that web application, he will be able to perform any activity he wants. We will close that web app and we will move to use case number 4. So let's log out and look at use case number 4. So in use case number 4, we actually have a company called Vendor X. And we have a user called Alex, who is part of the vendor support team from that company. Alex is performing some troubleshooting activities on a system within BT Labs organization, and he needs to access the system outside of office hours because he's generating some logs on that system and he needs them for a certain support ticket that BT Lab has open with Vendor X. So what will happen right now is that Alex will access the same published URL accessed by BT Labs employees. But this time, since Alex does not have an AD identity within the BT Lab organization, what will happen is that Alex will authenticate using some local privileged remote access credentials. Once Alex attempts to authenticate with the credentials provided to him by the BT Lab organization, he will be also prompted to go through a multi-factor authentication process. And right here, Alex is actually using Google Authenticator. So I'm just typing the code that I can see on my mobile phone from the Google Authenticator application. And once Alex provides the right code, he will be able to access the system. To note here that the PRA appliance can be integrated with any TOTP application publicly available on the mobile phone stores. So in my case, or in Alex's case, he has decided to work with Google Authenticator. Another vendor or another user can decide to work with another authenticator. Maybe it can be the Microsoft Authenticator as well. Alex will launch his privileged web access console, and you can see that Alex has only access to the Windows server. He will attempt a jump to that Windows server, and the difference here is that his access is not auto-approved, especially that he's requesting access outside of office hours. He needs to extract some logs, but he needs to inform the BT Lab manager as well of his activities. So Alex will provide a reason. So extracting logs, case number with vendor X. And he will send that request to the BT Lab manager. Once a request is sent, he will request the exact duration. So let's say he needs it just for a couple of minutes, and he will send the request. Now, if we open the inbox of the BT Lab manager, we will notice that a request notification will be received by the BT Lab manager. So you can see here that a new session authorization request has been created. It's request number 15, it's pending approval, it's Alex from vendor X, and he is requesting access because he needs to extract logs from the operating system, and it's related to a particular case number with vendor X. So then the BT Lab manager will respond to that request, and it will open a new web page where he can leave a message to Alex. So he will say, okay, go ahead, but don't restart the server. And he will approve it. Once approved, if if we go back to Alex's session, we're going to see a notification from the PRA appliance stating that the access request has been approved. Now, Alex can jump to the Windows server, and of course, we haven't given Alex the admin credentials to that server, so Alex will have the option to inject the credentials. As well, Alex can see the message left by BT Lab Manager that the request has been approved, but he cannot perform a restart after working hours. So he'll type on OK and automatically inject the vendor privileged user account that was given to him. The password is not known by Alex, so the password is never used on a desktop that does not belong to BT Lab organization, because again, Alex is using his own company's desktop to access my environment. This desktop has no VPN connection to my environment, and this desktop is outside of my network. It will remain outside of my network. So what will happen next is Alex will generate the logs he wants to generate on that server. And in order for him to extract those logs or to get those logs from the operating system, what he can do is actually go to the file transfer option. And you can see here that we've restricted Alex to do file transfer only on a specific folder under the C share. So what Alex can do is create the logs or extract the logs from his software, put them under the vendor logs folder under the C share, and then he will be able to download these logs using this file transfer tool. And notice here how Alex is only allowed to download the file, but he cannot upload any other file to that system, and he cannot access any other share to that system using the file transfer tool. And this is how we're restricting Alex in terms of file transfer, and any other third-party or remote user, third-party vendor from doing file transfer with any file share or with any folder on the operating system. So with that, I'm wrapping up the demonstration part. Just before we close out this session, I would like just to point you to a couple of really good white papers that we have on our website that discuss in details the zero trust approach. In order for you to have access to these white papers, all you need to do is go to the BeyondTrust website. And under the BeyondTrust website, we have a section for white papers. Under that section, you can find some really interesting white papers related to several compliance regulations, industry best practices, etc., but also a couple of particular white papers related to the zero trust model that I invite you to thoroughly read, because they are really very well written and really interesting topics to read. So I point out the following: the zero trust approach to secure remote access, also to Windows and Mac endpoint security, and the NIST zero trust approach. And with that, I would like to thank you today for joining me and sitting through this presentation. If you have any questions, please feel free to reach out to the BeyondTrust team. We look forward to hear your feedback, and we look forward to discuss with you your particular requirements and help you achieve zero trust within your own organizations and environments. Have a nice day.